here in episode 7, I wrapped 200 turns of copper wire around the bar just to see that the Earth's magnetic field, which magnetizes the bar, induces electrical waves into the coil. And sure it does. Then I go through the whole dissertation, or Lucy goes through the whole dissertation of what was realized, the current that was induced into the coil. Then the main purpose here was to brighten a couple of spots on the rebar, to clip the scope probes onto it along with a current probe to look at the electromagnetic waves moving through a conductor, now specifically a 1 meter conductor, which is significant. And the whole purpose of this again was to verify that the propagation velocity goes up as frequency goes up. Now bear in mind that electrical waves are considerably slower in a conductor. It's important to note that waves, when changing media, that's any wave in any wave, whether it's light or electrical or sound, when it changes media, it changes velocity. But the frequency remains the same, only the wavelength changes. Now the velocity in conductors has a very large variation. The power company has to deal with it by adding capacitance because of the long wires and the high inductance. But the velocity changes are substantial. To give you an example, as you'll see here in episode 7, that at 2 megahertz, the velocity is 66.6 meters per second, 66.6 million meters per second. At 15 megahertz, it's 143.8 million meters per second. And at 20 megahertz, at a lag of 6.5 nanoseconds, it's 153.8 million meters per second. And that's only 51.3% the velocity of light. Now, it's at this point in episode 7 that it's important to note that it's the rise time of the wave that is the acceleration and sets the velocity. I want to repeat that. It's the rise time of a wave that is the acceleration that sets the velocity. Now, it was Michelson-Morley experiment with what they call the interferometer, where they were trying to discount the ether for the solution as to what carries light waves. This is around the time they came up with the idea of the photon, and which I'll contend that the photon does not exist. It's actually waves in dark matter. At this point we come to the equation which establishes the velocity of light, which is c equals 1 over the square root of permeability and permittivity. That's epsilon O and micro O. This really gets complicated, and you can look into it's actually the calculation of capacitance and inductance in, and I would say dark matter, but in a cubic meter in 3 dimensions. Developed by the Scottish physicist James Clerk Maxwell, permeability and permittivity pretty much established a mass of dead space or empty space that conducts electromagnetic waves in 3 dimensions. You really should review episode 7 because there's a lot of details there. Dark matter resides just beyond the electron, and the universe is in a continual state of coalescence. There was never a Big Bang. It is continually precipitating. And this is where I the first time I described skewed dilation. Because what's actually happening is that we are under compression and we are headed towards the future. We're headed towards the center of the galaxy, and we get denser and denser and denser, but everything stays linear and uniform. I probably shouldn't have brought that out, but nonetheless, that's skewed dilation, which is actually what's happening. It actually go into more details much later in the treatise. Next, Brainshtein begins to establish the parameters of light waves. Lucy elaborates on the many physicists that contributed to the work on the velocity of light, which ultimately comes down to Maxwell's equations, which bring us to 299, 792, 458 meters per second. Now that later will be seen not to be true for all the colors, and I actually, or Brainstein actually establishes the velocity of each colors. He begins with the velocity theory of diffraction, and points out how the diagrams, even on Wikipedia, the diagrams of diffraction through a prism are in error. They're a complete mistake. Light, and if you look at it real closely, play with the prism in sunlight, light enters the first wall of the prism, changes angle, which is described mathematically later on. It stays collimated and straight. Now, in all the diagrams, in professional diagrams, in dissertations, show the diffraction beginning dispersion inside the prism, and it's not true. It doesn't spread out, it stays collimated. It spreads out or diffracts when it leaves the prism, because light has gone slowly through the prism. It slows down when entering a media and accelerates again to 299, 792, 458 meters per second when it leaves the prism. And all the colors leave the prism at a different angle. Then he points out how it's impossible to make a slit thin enough or square enough for light not to be curved or deflected by the edge. Light is infinitely divisible. He establishes that light waves are flat. They're always coming at you, no matter what direction you look at, it's coming at you flat. How they are not curved like sound or water waves like you've seen in water tank experiments where the wave comes out curves. Light doesn't do that, it comes through flat. Then Lucy does a really good job of describing a wavelet. It's a compression and a rarefication. Compression, rarefication, compression, rarefication. Never moves backward, always forward. Compression and relaxation. And she describes a light wave going through water and how it wiggles the molecules. Light waves with their energy actually impart that energy through vibration and wiggle the molecules against each other. Push the amplitude high enough and it'll actually boil the water. A light wave at 299, 792, 458 meters per second relates to 0.775365 femtoseconds. That's the short duration. That's how short the wavelength is. And again, that's the rise time that sets the acceleration and the velocity. And once again, Brainstein harps on that a wavelet will diffract absolutely by itself with no relationship to any other wave, and especially not phase velocity. Next, in episode 8, I think I'm a real cinematographer. And I play around with riding with Lucy on a bicycle. Just for a little levity. I think I just thought I needed to lighten things up a little bit, but not really. Then I have Lucy does a review, and this is to bring into light and hope that at this point in the process everybody understands that the propagation velocity actually changes with frequency. And this is an entire break from everybody else in the field of physics, but they're going to wake up and realize this is the truth. And then Lucy explains the math behind how light changes angle in a prism. Now, this is going to be another really big break with all of physics, because they're stuck in phase velocity. And I actually show how when light goes through a prism, naturally it slows down. The wavelength narrows as the frequency remains the same. So what you have, when you see a prism with the sunlight shining on it that comes in collimated as a circle on the prism, it turns into an ellipse and actually angularly chops up because the light is slowing down as it enters the prism. All the colors bend the same amount. It is the ratio of the tangents of the triangles of the outside beam to the inside beam. Nothing complex. Rotate the prism slightly and the angle goes away. Then we calculate the velocity inside the prism to be 203,259,286.5 meters per second. That's 203,259,286.5. I had to read that because it's not memorized. Then Lucy describes why the exit angle is so acute, and it's simply because it jumps back to the speed of light. She then shows the green laser and the green laser through a prism and the acute angle, how light goes everywhere. It's more concentrated in the beam, but there's a weak beam and a reflected beam. And the laser itself actually is not all one frequency. Next, Professor Brainstein describes how each color changes angle because it's exiting the prism at a different velocity. Next, Lucy shows the angle of each color, and Professor B explains the trigonometry and how the hypotenuse differences are how the angle is calculated. Lucy shows the equations that calculate the velocity of each of the colors. Then she compares this to the index of refraction, which uses phase velocity, which is in air. And then I do a little comedy and head to the shower. Next, we talk about Ernst Abbe and his refractometer. This establishes what they call the Abbe number, later to be called the V number, which is the index of refraction. Professor Brainstein then again discounts phase velocity, and the image on Wikipedia that shows the light diffracting inside the prism shows it dispersing inside the prism, which is a total error. Then Lucy elaborates on how the index of refraction directly relates to the anatomic size of the molecule inside the substance, be it diamond or glass or even the air, cubic zirconia. Each of these directly relate to the anatomic structure, which is how the waveform actually changes its angle by one color to the next. Then Lucy gives a little history of diffraction and the many people that have pondered this over the ages. Willibord Snell van Royer. That's quite a name there, 1580 to 1626. Claudius Ptolemy from AD 100 to AD 170. Johannes Kepler, 1571 to 1630. And René Descartes from 1596 to 1650. She then goes on to explain or describe the wavelet, the size of the wavelet. That's one little wavelet in femtoseconds. How it relates to the anatomic structure of the substance that it's passing through. And then she returns to the green laser and denotes the weak beam that is slightly diffracted up, and how it's a telltale that even within the coherency of the green laser, that it's not all one frequency, that there are narrow bands or narrow frequencies within its green spectrum that cause it to diffract uniquely. You'll see the weak beam, the long sweep, and then the concentrated beam, and then inside the prism, an angular reflected beam. And then Professor Brainstein restates that light waves are flat. Now in this case, the test and the experiments and all the diagrams you see, the source is the sun, 93 million miles away. The point here is if a light comes all that distance, comes at you flat. Then Professor Brainstein explains that his equation calculating the speed of each color is flawed, and in that it uses red as the base. Now this was an interim walk up to where later on he alludes to that the base is actually green, and it will be proved. Then in episode 9, I mess around with cooking just for fun, but actually it's to promote my science fiction Dilation, which is quite a good science fiction. It's a regular Buck Rogers story. Then Professor B gets serious about the speed of light by passing 3 colored lasers through a single slit, red, green, and violet. Now, since the geometry of all light, the geometry of all waves is the same, there's no difference between the geometry of the spreading wave, they should all be the same. There should be no difference, except that you want to understand that light does not spread like water waves. They don't go out in an arched pattern. They come out at different angles, flat. Say that again, they come out at different angles and they are flat. Now the reason for the interference pattern is as the beams magnify in space because of simple pinhole magnification, The angle increases. This lengthens the hypotenuse that makes the beam travel a greater distance. Then Professor B gives the details of counting the waves in the dark areas. These are the out of phase areas. Simple arithmetic to count the waves by the frequency and the velocity. Then you have to pay attention as Lucy gives the details of the math comparisons of the waves. Not many people will want to do this. This is not for the faint-hearted. But if you're brave, grab your calculator and try to understand the ratio of ratios. So you may want to go back and review episode 9 because it is accurate. Simply, if the velocity of light is the same for all the colors, then violet light should have more waves in the out of phase area than red and green. Simply, it does not. It has less. Then Lucy explains how both the frequency and the wavelength must be adjusted, and she gives the correction equation. And this is where the results of the math indicate that green is the base, and all the corrections go down and up from there. And that green light travels at 299, 792, 458 meters per second. So in episode 10, Professor B again explains how violet light travels faster than red light, that the velocity of the light is set by the rise time of the waveform. Then on a cosmic scale, light waves overtake each other, and the red shift of light needs to be recalculated. Violet light travels 188 million kilometers farther than red light in a year. Next, Professor Brainstein shows a chart of velocity variations charted against the natural logarithm. And since all waves are continuous, you would never see the difference. Then Lucy introduces the electron as transition matter in dark matter, as a transition between dark matter and real matter. And Professor Brainstein disputes the value of the electron at 9.109 to the minus 34. That the electron has an equivalent mass, and that's equivalent mass at 1.602 to the minus 18. That an electron is a juxtaposition of dark matter collisions caused by the core of an atom, like the nucleus of the atom actually precipitates the electron out of dark matter collisions. Next, he shows a double slit experiment that's not like the regular double slit experiment. It's actually a square hole. It's two-sided. It's both up and down. This causes the beam to go vertically and horizontally. And basically what it shows is that you cannot produce a square corner. Anatomically, when you get to the corner, it is ultimately round. Then Lucy continues the thought experiment of combustion part 1. And then Lucy describes how atom compression changes the shape of atoms and presents an alternate method of how atoms are actually held together. Next are the many details of the tank experiment and how in the beginning there was a specific volume and pressure, and how after combustion you end up with net less and a vacuum. That explosions are implosions with an exothermic reaction. Next, Professor Brainstein explains how the high energy is released, where this comes from. It's due to the friction and the acceleration as hydrogen and oxygen collide to make water. They increase in density and reduce in size, reordering their space. Now this actually describes the universe as we are increasing in density, decreasing in size. The heat is expanding entropically, and space is reorganizing in skewed dilation. Now, starting off in episode 11, Lucy promotes my novel, The Prost Probability. It's a futuristic AI novel where the inventor, Jared Prost, invented this machine that ultimately makes everybody rich and destroys the planet in the process. So it's all about espionage and him being chased by the CIA while he's trying to kill the machine. Then Professor B chases after the large energy that's exposed in this experiment with the thought experiment with the pressure tank, of how a small amount of hydrogen and oxygen produces some really large amount of energy. So Lucy sums up the distribution of volumes, which shows the very low distribution just by changing the volume you only end up with 269.69 joules, where the empirically stated equation on the energy produced by that quantity of hydrogen and oxygen is 3,337 joules, which is a very large amount for such a tiny amount of hydrogen and oxygen. Lucy elaborates on the 3,737 joules and how it produces 893.59 degrees C, or that is 1,640.4 degrees Fahrenheit. Then they chase the electron loss and evaluate the 3,737 joules to grams of work. Actually, the work done to raise a gram all the way up to 373 kilometers is what it evaluates to. They have to fire a gram into space in order to achieve 3,737 joules. And by analyzing the number of atoms colliding and creating each wave, they chase through causality how the energy was produced, and they chase it all the way back to the creation of the electron that fires through the electrode that causes the reaction to begin with, the catalyst, and how the electron emerges from dark matter. And then Professor Brainstein argues that hydrogen was created in nebula, in the plasma of nebula. A lot of people and scientists say, well, it was created in the Big Bang, but he believes, and I believe, that it was precipitated, and it's continually precipitated in nebula. Next, they look at the mass related as it relates to the lost electrons. When hydrogen combines with the oxygen, it gives up its electrons. And at 9.109 to the minus 31, the mass of an electron, when you multiply that times the actual number of atoms of hydrogen that gave up their electron, it's not even close to the amount of mass that was lost when hydrogen joined with oxygen. And then Lucy goes on to explain the unique properties of water, the mobility of the hydrogen atom, which is why you find that oxygen so easily combines with anything, because the hydrogen is just loosely attached to the surface and skates off at any opportunity. That's why you'll see iron oxide so easily. You expose iron to water, the hydrogen atoms disappear, and all of a sudden you've got rust. Then Brainstein shows how the electrons have a mass equivalence but no true mass. They're juxtaposition collisions of dark matter. Then he shows the source of the catalyst, where the electricity, the electron comes from. Could have been a battery or a capacitor that caused the spark. And then he explains how the electron is pushed off the ground of the electrode as an iron ion. The electrons are never free by themselves. They are always in a plasma attached to some element heavier than the electron itself. Then they describe how the iron ion collides with the molecules of hydrogen and oxygen, and the reaction begins. A chain reaction that's all over in 20 milliseconds. And then they describe the energy of each action. That's the creation of each water molecule, individually, each little molecule created, and then they sum the energy. And then working backward from the known total, he extrapolates the solution. The calculations indicate a very large reaction, but we know that the empirical values are probably correct. Many of the waves cancel each other before they reach the surface of the cylinder. And the empirical value is probably correct. Otherwise, the chamber would be destroyed. And later we see that's how bombs are made. So there are many details that are brought out in this episode 11. The separation radiuses are really interesting, and I think they're quite accurate. So you might give episode 11 a review and take your time going through it, because the math is heavy. So then in episode 12, Professor B is cutting up some quartz, some natural quartz, with a diamond saw, while Lucy goes to the opera. She goes to the opera to promote my novel, For the Love of Annie Dupree. It's a story of women's suffrage of the 1890s. I know it's shameless promotion, but I've got 5-star reviews from women readers. Worth the read. Then there are 2 stable parameters, the tank at 1,000 cubic centimeters and the 434.788 septillion molecules. That's an actual number that's measurable. And at 893 degrees C, we're able to calculate the water molecule to have a radius of 81.88 picometers. Then Lucy describes the energy waves, which are not linear down through the tank, they're spherical oscillations. She then shows the energy of each molecule for the summation. Try your hand at the quantum calculations you see in the treatise, or even from the video, and start seeing quantum mechanics as hard crystals instead of the magic nuclear forces that are so complex that probably are much more realistic as solid calculations rather than vaporous oscillation calculations or spin factors. And then Lucy compares the experiment to the internal combustion engine, which is really fascinating because the calculations of the really high energy explain why the internal combustion engine works. She then counts the electrons in the conventional models and shows that the electron is not the lost mass.
And that is where the weight and volume went is invalid, because of the misobservation of gravity. Electrons are wave focal points of dark matter collisions that only exist for short periods, which the professor will show later. Thus looking for the missing 0.155712295 grams is invalid, since mass attraction is invalid. What is valid is the new compound of water now produces a vector field that weighs 1 gram per cubic centimeter, when the entities of hydrogen and oxygen occupied 1.207244 cubic centimeters before combustion. The volume decrease is directly related to the electron vector field leaving, and compares to the 2.87% of space occupied by the proton as shown in slide 216.1 on page 151. 97.13% of space in the atom is the dark matter vector field caused by the proton. As seen in slide 216.3 on page 152, 2.87% of the atom's volume, or 1.435% of each atom, is gone, as the hydrogen is shaded from dark matter collision by the oxygen. So here is water. It is now visible, and you can drink it.
Then they count the atoms and find the dimensions and the weights. And in this, only the brave will follow the calculations. It's pretty involved, it's all real, and it's all accurate. So electrons are vaporous entities that only have a short duration. Now, then Lucy goes in to explain vector fields, and then finally the description of heat.
So, what is the point to all of this? The point is that heat, which is the energy state of the molecule, is organized in three-dimensional space. If you alter the volume, the heat energy will rise temporarily and dissipate entropically into the surrounding space or materials. Combustion is matter colliding, smashing together, combining, increasing in density, thus reducing its size in space. The heat energy it had before it condensed is redistributed into the surrounding space. This heat energy caused all the other gases to expand as their molecules became more energetic, as is seen with Gay-Luszak's law. The point is that an explosion is the reaction to the action, which is implosion. This describes the universe as skewed dilation. Two things are happening: mass is increasing, and the universe is expanding at the same time, and heat is molecules in motion, not flying around, but changing spatial size. This is energy. It does not exist except that matter possesses it. The idea of energy independent from matter as pure energy is a misobservation. We looked at this as a simple combustion consideration. Now, look at it in the large-scale reordering of matter through time.
Heat being the transient state of matter's activity, always entropically dissipating. Explosions are implosions that cause an exothermic reaction. And then finally, energy is something that matter possesses. Fusion on the sun is dark matter pressure. Stars are element factories. So this completes the review of the first 12 episodes. Episode 13 is in writing, and there's much more to go. If you'd like to know the end of the story, you can buy a copy of Perihelion Engineering, the Universe Not in a Nutshell. You can find it on Amazon.com.